Hello, very good evening, sir. Am I audible?
Yes, Ishida, good afternoon.
Yeah, pardon me. Very good afternoon, sir. So I think you can start with sharing your screen and starting
Oh,
the practical session.
okay, sure, sure.
Yes, sir.
Thank you.
Thank you, sir.
Okay, hello, participants. So, am I audible?
Yes, sir, you are audible.
So, Ishita ji, if I
Yes,
want
sir.
to share something, can I share the link so that participant can open it at their end?
Sure, sir, you can. You can share the link in the chat box, or if you want, we can even share it on other platforms we are connected to the students for, if you want to share a specific PDF or any other document itself.
So, there is
Yeah.
two links I'm sharing. One I've already shared,
Yes, sir.
and one more I'm sharing. Okay, so I think you must have received two links.
Yes, sir.
So
Two
the
links have been shared to all the participants here.
Yeah, so two
Mhm.
links are shared.
Yes.
So participants can actually go to the first one, which is image denoising with autoencoders. So there are two parts, right? I guess two this thing is there.
Yes, sir. The whole session is divided into two sections for
Yeah.
today.
So you said
Yes, sir.
that it is no, that's okay.
Mm-hmm.
The in the second half also there are two parts. One is
Okay.
representation learning and another is
Hmm.
image denoising.
Yes, sir.
So the first one link is for image denoising, the other one is for representation learning.
Sure, sir. I think students have received the link and they will
So
use it according to your guidance.
yeah, so what I hope they're listening me, right?
Sure, sir. They can. All the participants.
Yes.
You are clearly audible to them.
Okay, so what you can do, participant, is you can actually download these Colab files and save it on your local machine and then experiment with it. You cannot edit this file, but you can definitely download it and then you can edit it. So I would request all the participants just download this first one, image denoising file, and save it in your drive. Similarly, the second one. Then we can start with the first case, image denoising. It will take around 40 minutes, 35 to 40 minutes. And then we can move to representation learning, which may take little longer because we have three exercises there, right? So once you have downloaded and saved on your hard drive, I mean on your local machine, you can just let me know. Then we can start with the first set of the hands-on. Yeah, shall I start describing? Could you download them on your local drive?
Yes, sir, they are able to. I think we can start and then students will continue with it.
Okay, okay. So I'll first go through the first part, image denoising with autoencoders. So these are all part of our regular courses. So one of our MTech students, Mr. Vikas, has prepared this. So he has actually extended from what our tutorial or lab exercises are there. So this is basically image denoising with autoencoder, where we'll be implementing basic autoencoder architecture using the MNIST handwritten digit dataset. We choose MNIST handwritten dataset because I guess it is available freely in the public domain, and we may not even require to download them. We can directly fetch it. So unnecessarily, it will not waste the our hard space. And then we will perform the autoencoder based denoising, and then we'll visualize the different features and the results for reconstruction after the denoising is performed. So there are, I guess, 5 stages, 6 stages are there, and then uh, so if you know a basic coding in the Python, and if you developed anytime neural network, I guess it is pretty easy for you to follow. The stage one, you can see that there are libraries, various libraries associated, which we have invoke, right? And we have included them with some uh, seed values of the random, because every time if you run it, then the result should be consistent. That's why. In the stage two, we will load the data. So for that, we can fetch it from the available data set, right? And so this is standard 28 cross 20 images of handwritten digits from 0 to 9. We can load them. After loading and putting in the groups of 100 images, what you can do is we can add noise. So you can see that there is a function which is there to add the noise. So you can use that rand_n function, which will add the normal Gaussian noise of the certain mean and the variance. So here we have used 0.5. You can change it. You can actually while you will be doing the experiment. Okay, but once you can run it through this result, so that you will be comfortable with basic results, and then you can experiment. In stage 3, we will be defining the autoencoder. So as you discussed in the class, there are layers in the encoding steps and the layers in the decoding steps. So you can see we have included the 2D convolution. There are 2 layers of 2D convolution, 3 ReLU functions, 1 flatten and 1 linear map, right? So starting from the size 3 by 3 kernel size of the 16, then we increase the size after passing it through ReLU. Once again, we'll pass through ReLU, flatten them, and then map it to 128 dimension latent code. So it's a linear map which we have defined there to map the 1568 dimension vector into 128 dimension latent code. Then we will pass it through ReLU. In the decoder, it will be exactly complementary. We'll first pass it, so we'll make a linear transformation back, unflatten them, perform the transpose convolution, pass it through ReLU, once again transpose convolution of the complementary sizes, then the encoding, and then we'll squeeze the values between 0 and 1 by using the sigmoid function, because in the input of the MNST, if you have experimented ever, all the values lies between 0 and 1. So we'll make sure that after the processing done by the encoding and the decoding, the output should be comparable to the input, so that we can write down some loss function in the real sense. Okay. Then we have defined the loss function as the binary cross entropy between the reconstructed X and the input X. Step 4 is the standard lines of the code to invoke all the training related parameter like um, the epochs and the loss function and optimizers and all these things. I think these are pretty straightforward because okay. And then in the stage 5 we have written the lines of the codes to visualize all the denoised outputs, right? So you can see in the output, it will show the input original set of the images, then the kind of the noise we have added in certain images, and then after the denoising is performed by the autoencoder, you can see those images are getting cleaned. I guess any issue till now? Are you able to follow this?
Yes.
Okay. Then in the stage 6, we put very interesting visualization because all these are the images of size 28 cross 28. So basically, they are 784 dimensional vectors, right? So 784 dimensional vectors or 128 dimensional latent vectors are hard to visualize. So TSNE is a work which is done by Hinton, which is capable of representing any high dimensional vectors on a 2D plane so that we can visualize the results, right? In a vectored dimensional form, in a vector space form. So the code for that TSNA visualization, which is available free, no need to invent it, right? So that code we have put over here so that you can directly use it. And then for the different inputs like original image or noisy image or image after the denoising, for everyone we put the plot function with respect to the TSNA output. And these are the outputs, so you can see and visualize. And the first one is the original image. And then when we add the noise, how the uh, clustering is there. And then after the denoised images. So what you can do in the experiment part, you can actually change the levels of the noise, the variance, I think which we have written 0.5. There you can put different variance values. You will immediately realize that there is an effect on the TSNE and as well as the output also. So this part as well as the here also you will find, right? So if you increase or decrease the noise, it will be reflected over here, as well as it will be reflected on the denoised output. Similarly, this effects you may observe in the TSNE based representation visualization, right? So yeah, so I mean, you can now start playing with the code. Maybe you can one more parameter which you can change is the epochs possibly. I mean, we are trying to give you some hints, but you may change it even. Okay, so so here there is a epoch, so you may change this at your level, and then see what is the effect on the output. You may even change these structures if you like. Okay, but then you have to be careful by matching the dimensions and all this, right? You may insert one layer in the encoder and one layer in the decoder and see the effect. You may actually even shut off one of the layers and see what is happening, right? From here, you can actually add different type of the multiplicative noise, the variance, right, values, and then see the effect. So these are the few things which you can experiment with data set. And if you are more comfortable, you may change even the what you can say, your input, and then you can redo the experiment. So I would encourage you to experiment. So I would again repeat, you may not be able to change this file, but you can download it at your level and then open in the collab, and then possibly you will be able to modify. I hope you are able to do it. Anyone who is doing it first time, or you are comfortable with basics of Python coding and all?
Participants, you can unmute yourself to answer the questions.
Okay, you are able to do it. Good, good, good. Please continue and experiment for a while so that you can appreciate the effect of the autoencoder and how it is performing denoising. You can see the result, you can see the TSNE visualization, try changing the noise, epochs, maybe add, delete layers. But you should be careful while you are doing all this activity. Basic skills in Python is expected. हाँ तो चलते रहता है।
Hello, sir. Can you share the link again? I have joined now.
Yeah, sure, Kush. Just wait, I'm sharing it.
Can you please tell about TSNE once again?
हाँ जूही, बोलिए.
TSNE एक बार बता दीजिए.
No, no, no. The problem is, even though we have not studied the case, at least we contribute and instantly we can with the flow. Students will not.
Yeah, Joohi ji.
Yes, sir.
So TSNE, if you read the paper by Hinton, it's a visualization tool which can actually project any finite dimensional data onto 2D plane. So suppose I have a 128 dimensional vector, and if I want to see this vector, it is impossible for me to visualize it, right? And if I have such multiple vectors, and if I want to look at the clustering or grouping among them, it's tough. So in the paper by Hinton, they have come up with a vector space based tool which can actually project any dimensional data, any finite dimensional data on a 2D plane. So you can visualize them as a 2D R2 structure. That's the tool. So code for TSNE is available freely. So in this particular example, in the stage 6 of image denoising, we have incorporated the required portion from that TSNE code into this here. So you can experiment with that. So that's the purpose.
Okay, sir.
So if you see the code, Juhi, on a top, stage 1, if you look at,
Yes, sir.
there is a library from where we have fetched the TSNE. You can see that.
Yes, sir. SK-learn manifold.
Correct.
Sir. Uh, sir.
Yes, please.
Sir, in the stage 3, where we are defining the encoder and the decoder, since I haven't worked in this encoder decoder thing. So, like in the morning, I was asking about the 1D vector and the signals, like what will be the architecture. So yeah, because we are using images, so we are using a convolutional layer. Similarly, we'll change the input vector, then this architecture will change, right?
Correct, correct.
Of the encoder.
Yes.
So second question, like we are doing just the reverse process in the decoder. So we
Yeah.
are starting from linear and then unflattening it, then doing the
Yeah, exactly complementary you have to write down. Decoder will be exactly complementary of the encoder, right? Jui, you are not audible. You are not audible, Jui. Hello.
hello.
Yeah, you were not audible.
Uh, okay, sir. So sir, in the decoder part where we are applying the linear, then unflattening and doing the convolutional transport. So sir, the nonlinear activation value that we have applied in the encoder thing, instead of that, we are using sigmoid in the end.
Mm-hmm.
And once we are using ReLU, so sir, how this translates, because we are
No,
applying ReLU 3 times in the encoder.
no. Sigmoid is just to map the values between 0 and 1 because your input MNS data set has the value between 0 and 1. So if I want to write down the loss function between input and an output, then my codomain should be same. So to make the codomain same, after the processing, we have passed it to sigmoid so that all the values will be proportionally between 0 and 1. And then we can write down the loss function. That's the purpose.
Okay, sir.
ReLU we have introduced for nonlinearity. So meanwhile, if you guys are comfortable, I am putting one more link where different data sets are there with what you can actually experiment. So you can go to this link and then you can use different data set from medical or different domain, right? But for that, when you do this, you can save this link for a later. Whenever you do this, once you change the data set, your coding will change accordingly. So be watchful while you change the data and re-perform the experiment. Especially careful about the dimensions of the kernel, input, output, all those things. Okay. And then you can use it. Even you can change the type of the noise also. So if you look at the file, we have experiment, I think, with the Gaussian noise. Here it is, right? So you return randn, right? So instead of that, you can actually even consider some other type of noise if you are working for a specific problem domain. And if you know the statistical distribution of the noise in that particular data, so that you can invoke that noise, maybe relay or something else, and you can experiment. So that is also one parameter where you can change and redo the experiment. Yeah, hope you are able to do it.
Yes, sir.
Can we switch to the next one in 5 minutes? Or you need more time?
Have 5 minutes more.
The salad sometime back. So, in spite of all this, she kept her patience and went on dealing with every small thing or every other thing. Again, that is which had made the richness to them.
ढाई बजे कितना होता है?
Okay, good afternoon, everyone. The second part, we start with representative learning with autoencoders. In this, we use good afternoon, everyone. Am I audible?
Yes, you are.
Yeah, actually, I am Vikas, sir, just busy on a call. I will join in sometimes.
Sure, no problem. Please continue.
Okay, thank you. Okay, in the second part, so we begins with representation learning with autoencoders. As we see in a previous practical, we use same dataset MNSID. It's basically 28 cross 28 image with handwritten 0 to 9. I think this link is also shared with you, so you can download and run in your system. Everyone has link?
Yes.
Okay.
Yes, sir.
Okay. So basically, this representation learning contain three separate notebooks or three separate parts. In this, we first with convolution autoencoder on MNSITV TNSE visualization. So what we done in this, just to import libraries. For every time we run the same code for the randomization. If availability of GPU, then run on GPU, else it will shift on CPU. This is a parameter 64 dimension, latent space dimension of 64, batch size is 128, and learning rate is 0.0005. Here we load a MNSIT dataset. It's basically fetched directly from online, so no need to upload and set the path for it. Okay. Okay, now this is our coder part. In this part, we define first convolution layer, then for a ReLU, because it's a first we add the image as an input, clean image, then we try to compress it, or then we try to generate back which original image. So that's why we use maxpool 2D. Here also we define kernel size of 3. So same encoder of structure, then flatten, linear, and ReLU. Also the latent dimension is here 128. So we basically 784 dimension to reduce and then 128. So basically linear layer. Same way what we done in encoder part, we do here decoder. Kernel size 3, same dimension, but it's opposite. Third part, we call it our encoder.
Excuse me, sir. Why did we use dropout here?
Sorry?
Dropout in the above code. in the decoder and encoder.
Yeah, dropout basically for so image basically 28 image. It's a compression of image. We try to store less into dimension. And also for to regularization and to avoid overfitting. To avoid overfitting, we use dropout. Also here the mention of batch 30 to 28, it's a 64, so it's a huge amount of difference. So that's why use dropout to avoid overfitting. Okay.
Yes.
Can we change the value of dropout in the encoder or decoder? They both have to be same. Like if you are using 0.3, they both have to be 0.3.
Yeah, you can change, but if you change the data set and size of the dimension of the original input image, then also you change. But if you change the data set, then also dimension of each layer is also important. So if you change the image,
No, like for the same data set, like if I'm using dropout of 0.3 in the encoder, can I do it 0.4 in the dropout of the decoder or not?
that's mean here we use dropout 0.3. Here,
Yes, and here we change.
if you change, if you same here 0.3 and change here 0.4, then a model might be overfit.
Okay.
Hmm.
We have to keep it same.
Yes.
Okay, okay.
So you can try with a different dropout. Can the reflectance on a last stage of TMC or also in loss. Okay. Here it's a basic training function we define to encoder. Then epochs, these regular things. Here we define original image or a reconstructed image, so difference between it. Here we call our main function, so that's why all training loops and then visualization is a one. We try with
So why we used MSc loss?
sorry.
Why we used MSc loss? The criteria.
Okay, you can use a different loss. If you try with a binary cross entropy, you can also change the reflecting results. Or one more thing, in MSc we generally define a norm of 2, L2 in equation. You can also try with L1.5 or a L1. So if we, what actually happens if we means MSc is a L2, norm 2. So it basically try to minimize their norm 2. But if we change to L1.5, so what actually happened? It shifted to L1.5. So it's a basically non-linear mapping. In a further notebooks, we also done with L1.5 and L2, and both is a compare. Okay. But to show the actually different between L1.5, L2, so that's why we use here MSC. You can also try with different loss. Okay. In some cases, you might notice that after some epochs, loss is constant. So in that case, you can also change the learning rate. In our case, we use 0.0005. Can change a different, try with different loss. Okay, then here it's our original input image. Then we try to compress it, and then with the encoder help, we try to reconstruct it. So you show the difference between the original image, it's a reconstructed image.
What are the dimensions of reconstructed image?
It's the same dimension. In a decoder part, if you move here, batch 1 2828, so it's the original image we get. Dimension is same. Okay, this is our first part. Now you can try it. And let me.
So we are visualizing and reconstructing that again.
Sorry.
We are visualizing the input image and then reconstructing the same image
Yes.
with the
Yes. Yes. This. Also, this is a latent space. It's a 128 dimension of single per vector. So basically, compress image, latent space. So original image latent space TSNE. This is a reconstructed image. You can see the difference here. Each dot is in 9, so 9 is blue, 2 is green, so it's green. It's a
Sir, what exactly is representation learning in this? Because we are visualizing the input and of the encoder and then the reconstructed output of the decoder. So what is representation in this?
it's a compact representation of latent.
Okay, the latent dimension or the vector that we are using in between.
Okay. The input image is 28 cross 28, and the reconstructed image or the latent space is a 128 dimension. So if 28 cross 20 is a 784, and we try to represent it into 128 dimension. It's a 784 dimension is a huge amount. So we try to represent in 128 latent.
So sir, here we are seeing three images. The original image, this is 784 cross 1.
Yes.
And this latent space is 784 converted to 128 cross 1.
Yes.
And the latent space 128 cross 1 again converted back to 784 cross 1.
Yes, reconstruct.
Okay, so we are actually seeing the representation learning in the form of the latent space, how the high dimensional vector is converted to the lower dimension and then again reconstructed back.
Yes, but with norm L2, norm 2.
Okay, the loss that we are using on regularization, that is L2.
Yes.
Okay, okay. And we can change the loss function or the regularization method that we're using, and this will impact the latent space, right?
Yes.
Okay. We can further reduce the latent space from 128 to like 64.
Sorry.
We can further reduce the latent space dimensions.
Yeah, can reduce.
Okay. So is there a method to decide like till what dimensions we can reduce?
No, it's not any fixed method to decide it.
Okay.
Everyone able to do it?
This TSNE part of code is taking much more time.
Yeah, I think it will take 3 to 4 minutes. Yeah, maybe more.
Sir, what do we have to do? Do we have to train it on different data sets?
Yeah, you can try. But also, so about dimensions, if you change the input image dimension, so all layers dimension also change. In our case, is 28 cross 28. If you take with another image, dimension will change.
So can you give an example from the data sets link that sir has given? Like there we can see a lot of image data sets. So we
Sorry?
have to apply on image data sets only.
Can you repeat your question?
The data sets link that sir has given,
Mhm.
Angel Cruise Route data set
Mhm.
link that we have.
Mhm.
There are a lot of image data sets over there.
Mhm.
So we can apply to any one of those.
Yeah, anyone.
So we'll have to check into the dimensions
Yes,
of whatever data set we are going to download.
yes.
Sir, suppose if I'm using FM and ST, then do I need to change dimensions?
Yes, depending on size, dimension of new data set can change.
Okay. So just I need to change the name MNIST to F and change the dimension. Just add F MNIST and
For that, you need to rewrite the loading data set part again
yes, sir.
here.
No need to import any libraries.
Now, if it's available on directly fetch from library, then you can change, but else you first download to your local system, then you path it and then use. In Colab generally, you store in a Google Drive, then you use.
Yes, sir.
Yes. Participants, are you able to do it? Juhi, Ishita, are you able to do it?
Yes, sir. I was looking into the data sets that you have given on the link.
Huh?
Uh, but sir, I'm not able to understand it. From where should I download those?
When,
Because those will not be uploaded directly. So some
so,
of the links are not opening.
yeah. What you need to do is you have to first download the data on your drive, and then you can actually link it. So your initial stage where you are loading the data, setting up the path, those part will change. And also if your data set has a different set of the images and the dimension, you can change your filter size and maybe the number of layers, everything you can change.
So sir, we have to do the data pre-processing part and then apply it like from the encoder class that we
Yes.
have in
Yes.
the code.
True. Not only that, I'm saying even you can change the architecture as well. अगर आपको लगता है कि this many layers are not sufficient, you can increase, decrease the layers and the dimension, everything you can do. See, this is one example. Now you can scale it up, you can scale it down. Why MNIST is chosen? The reason is it doesn't require the downloading, setting up the path, these, that, folder create करो, वो सब जरूरत नहीं है. That is why. And someone was asking me in the morning session about some work. So will it be applicable to other and this, that? So now once you change this code to for some other data set, you will immediately realize you have to change a few things. Otherwise, you will not get the same accuracy back. So that is the challenging part in the machine learning, and there is no theory for it. That how do you set the number of layers? How do you set the size of the kernels? What nonlinearity function you will be utilizing? These are not written. See, machine learning has a broad guidelines. Said that you need to give sufficient data, you need to have a sufficient architecture, appropriate loss function, optimization. These are the broad guidelines, and then you leave it to the machines to learn. So that's the beauty actually, and that gives the generalization over different data sets. So in both the experiment, whether it is denoising or representation learning, so especially in the representation learning, you see that when you change the loss function norm, you can see it's the outputs are getting different, right? So from L2, if you make it L1 or maybe L1.5, then you see your outputs are getting changed because you are forcing the weight to be different. So Vikas has created multiple this thing notebook so that you can actually visualize it easily. Otherwise, you can pack it into one file also. I mean, if you are clear about the other things, right? So you can see entire experiment is done. Now you look at this result, for example. So here you see there is an original image. Look at this one. Are you able to see this?
Yes, sir.
So, so this is actually 2, which is cut. Okay, so there is a portion of 2. Some handwritten 2 is written. Now, if you invoke L2 loss, you see that L2 is going to maximum likelihood, which is like a low pass filtering in the signal processing. So it is trying to connect this point to this point and trying to elongate this. So the L2 is understanding this is actually 8 and 2 is incorrectly reconstructed as 8. You can see that. But the moment you invoke L1.5, the norm dimension is less. Now you're putting more penalty. So your weights are adjusted in such a way, it will go more close to what is there in the original form. And it will not try to average out the effect. So you can see here it is trying to reconstruct not as 8, but trying to go towards the 2. You can see that. Even you can see in this 9 also, where there is no line in between, but L2 has connected it. But L1.5 has not connected. You can check 7. So these are the effect of different representation which we are enforcing while we are putting different loss functions. That's what it is, the meaning of the representation learning. Are you following?
Sir, sir,
Yes.
sir, one of the data sets from the link is for visible human data sets. I've shared the link in the direct chat. So there we can see that the CT scans after freezing, CT scans prior to freezing. There are so many things. So out of this, how we will decide like which one to upload, or like how we will look into this data set and try.
I didn't get the question. Basically,
So
you need to decide what kind of data you want to do for denoising or whatever application. You can decide, you have to look at the data first. See, the first thing which most of the practitioner is missing is first study the data.
okay.
It's not like that you get data, you just download it, start doing the experiment. No, it's wrong practice. You have to study the data, see its statistics, whether there is a class imbalance, whether augmentation is required, whether any pre-processing is required, is there any outlier. So all these things you have to see first. In the data analytics course, all this pre-processing stuff is being taught so that you can first of all understand the data properly. Don't go blindly to implement it somewhere. Otherwise, your machine will give you some result which is not interpretable by you, and then you will be puzzled. First, understand the data, see what is your problem definition, formulate the problem, then tune your data accordingly, and then experiment.
Okay, sir. Got it.
So this database contain many data sets. So it's a platform combining all the data sets, sir.
No, this is basically one of the link. Can access the data, but this is not any platform. For a download dataset, you may use Kaggle, direct from the website of any dataset like medical image or any remote sensing image.
Medical images, computer vision image, data sets, everything has been given.
Yes.
So we can take like Kaggle data sets, we can use this image for further practicing or research work oriented, or only for practice.
Yeah, you can use for also for research in Kaggle.
Okay. So based on this image thing, when we come to image thing nowadays, all the deep learning algorithm will be focusing only on finding metrics, metrics thing and hyperparameters. So when we move compared to this transformer and autoencoders, based on this, what is the future thing we can apply for research oriented this? So I went through a lot of papers. Everything is focused. Finally, the results will be focusing on like precision, sensitivity, specificity, accuracy, F1 square. They are finding out. So nowadays, a lot of technologies like LLMs and like transformer and auto decoders, encoders are getting upgraded and coming in medical images or normal images. So what type of researches we can focus instead of focusing on previous accuracy? Can you hear me, sir?
Yes, yes. Sorry, but actually also I am also M.Tech student, so I'm currently doing my coursework. In a few minutes, sir is coming, so they will answer.
हमारा थोड़ा लेट हुआ था, 1 आध मिनट लेट हुआ था, है ना? तो मुझे अभी उन्होंने बोल दिया था ना कि आप कर लीजिए, तो मैं शायद 2 क्लास का कर।
No. So,
Yes.
can you please share some resource for data analytics?
Yes, I will.
1 or 2 links for beginner.
Sure.
Sir, can you hear me?
Yes.
Yes, sir. As you mentioned, you were like MTech student, right?
Yes.
Yes. Can you get some thing related, as my field is from biomedical, so I need some. Can you suggest some guidelines how to upcome with this deep learning and AI things? What are all the sources we can follow to get learn newly, and we can get upgraded in this?
Okay, in chat box, I will share some important links. From that you can find in our coursework from that.
Okay, everyone. So, hello, am I audible?
Yes, sir, you are.
Yeah, so there were some questions about some resources. So we have shared some links where you can look at data analytics, deep learning, and some mathematical aspects of the deep learning. I guess this resources may be shared to all the participants.
Yes, sir. As currently we do have them in the chat, I can copy it and provide it to them on other platforms too.
Okay, okay. Thank you. Are they doing it? Are they getting the experimental part? I hope they're doing it.
Participants, please, you can respond through chat box or even by unmuting your microphone.
Yes, sir.
Great. So you are enjoying?
Yes, sir. I'm enjoying. I don't know about the others.
Okay. Okay, great. Great. Yeah, Ishita, what I will do is I will share the slides and this links and code everything
Sure, sir.
in the email as well. Okay.
Sure.
So you may share it to all the participants so that some of them, I think they have missed the morning session, some are joining late, so all can be benefited.
Sure, sir. I'll convey all the materials and provide them on their distinguished platforms wherever it's important.
Yes, yes.
Yes, sir.
Sir, are you back?
Yeah, I'm here only. I was actually on the call, different calls.
Yeah.
Yes, please go ahead.
Sir, I have asked some doubt that time you were not there initially. Actually, I have some research-oriented question in this area.
So are you doing PhD?
Yes, sir. I'm doing
So are
PhD.
you faculty there?
No, actually, I'm full-time. Now I joined as a faculty here.
Okay.
So still, my work is going on. My area of research is medical imaging. Using a medical image processing.
Okay.
So here my question is, I went through a lot of research things when I come to TB cases, X-ray, CT, all those things.
Mm-hmm.
So past 1 to 3 years, from 3 years, the research thing is going on. The final results they are focusing whether because of real-time image, not getting real-time images. So the people are working with Kaggle dataset or some other public datasets, able to just do some modification like they go for comparative study of neural networks or something else. They will be doing some metrics modifications or doing some pre-processing or augmentations, and the final results will be like it's like they will be showing like they will be increased with accuracy, precision, F1 score, specificity, and sensitivity, like type of metric measurements. So when we go for submitting some papers in this research, the papers are getting nowadays somewhat they are rejecting due to there is no real data. And the second thing, you people are focusing on like this oriented metric measurement or all those type of things. So I went through some other papers recently, like transformers based all those things. So some of the research things are they have added some transformer things, and I came to hear that the image clipping and captioning all those things. So I need some future scope and future implementation idea in area how we can add for our research to further movements.
So Rajesh, I'm providing a link
Okay.
in the chat box where you can look at how to conduct research in medical domain with a significant contribution.
Okay.
You can you see that? I have shared a link.
Yes, a Springer Nature link.
Yeah, this is one of our recent works which we have published. You can look at it, download this, read it, and then if you find some difficulty, you can tell me. But I believe if you read this thoroughly, you will understand how to conduct a good research in the area of healthcare while using machine learning technology.
Okay, so it's like a journal. We can look for future publication also in this.
Yes, yes, yes.
Okay. It's like it's open source, freely thing, sir, or we have to pay for that?
But I guess nowadays everything is on one nation, one subscription. So are you not covered?
Sir, I'm not getting.
Nowadays, institutions of the national importance are under one nation, one subscription facility. So are you a student of IIITDM or some other institute?
No, sir, no, sir. Here, I'm from Chennai.
So what is your parent institution?
So it's SRM.
SRM. So SRM must be having the facility of one nation, one subscription.
Okay, I'll check with that, sir.
Yeah, under this scheme, Government of India has released all the resources for free. So I think you should be able to download this.
Okay, sir, I'll go through this. Okay.
Yeah. I hope this answered your query.
Yes, sir. Can I get your email ID? If possible, we can chat.
Yeah, it's there. It's there on the website. Just go to type my name, IIIT Vadodara, you will get it.
Okay, sir.
Yeah.
Okay, sir. Thank you.
Hello, everyone. So I think as the time is up to end for this session, and we are mostly done with all the concepts that were to be done in this session. I think we can move on to the doubt or queries session. So if any participants have any doubt, queries regarding the practical session, can get it resolved through our speaker at this point, because we'll be ending the meet around 4:30. So please be quick in asking your doubts.
Sir, how to import the fashion MNIST dataset?
Sorry?
The fashion MNIST dataset. I'm having trouble in importing the datasets.
No, first you need to download it in your drive
Okay.
and set the path according to.
Okay, sir.
So it seems like that we do not have any more queries from our participants. Can all the participants please confirm the same?
If there are any questions, any queries, anyway, if we can help you, please let us know.
The following quiz and assignments will be available around the time this session gets over. All of the participants can attempt it after that. So I
The link,
think, yes.
yes, sir, the link about that you have given for the deep learning
Yeah.
is need to purchase, because I don't think that there is any option to download that book. Other two PDF is downloadable, but this one is not. I'm not able to download.
Ashutosh, in today's era, you are asking me how to download a book.
No, sir. This one giving a cost of
No.
$100.
Again, you are asking, are you student or a faculty?
Student.
So you are smarter than me. You know how to get it download.
From
Why are you asking such questions? I should ask this question to you.
No, means this link is not from other site. I can from somewhere proxy I can download it, but from the link which you have given from there, it is not able to download. That's why I was saying.
See, when we are praising Ma Saraswati, we should not look at Ma Lakshmi. And when we are praising Ma Lakshmi, we should not look at Ma Saraswati.
Yes, sir. Got your point. Thank you.
So you are a student, you praise Ma Saraswati and
Yes, sir.
get yourself learned. Pragya.
Got your point.
Yeah, please go ahead. Yeah, Pragya ji, बोलिए. Yeah, someone has asked on the chat, and Anand Sivaram, how does one get used to coding deep learning stuff? Anand Sivaram, if you are there, unmute yourself. Anand Sivaram is there? Or you are having issue with your mic? Okay, I'm asking you. You write down on the chat box. Have you done farming ever? No. What if you want to do farming? How can you do? You have to go into field and do it. So machine learning or deep learning or any coding is an experiential learning. You have to start doing it. While you do it, you will automatically learn. You will keep on learning. Start writing the small codes. See, today we have given 3-4 Jupyter notebook. So you know how to download, how to import the libraries, how to write down the typical network, small network, how to write down the loss functions and other stuffs. So you start building your codes like this in a small modules, do it, you may fall up, rise again, do it, keep on doing it. You are from known CS. I am also known CS background. I'm an electronics guy. If I can do it, you can also do it. Okay, one more is, would you encourage the use of AI in coding? Yes, but you have to earn license for it first. What I mean is, if you want to use some ready-made function, you should know what that function is doing. Once you are sure, then you can use that function. Okay? It's not like use of mobile. It should not be like a use of mobile. First understand, be confident, and then you can use it. There is no need to rewrite it. But without understanding, if you do, you will be going in a dark, for sure. Yeah, any more questions? Any more questions from any participants?
Yes, sir. I have written in chat box.
You can tell me.
Sir, yes, I audible, sir. Sir, just from being from non-CS background, and how I can learn these deep learning concepts like this.
Learn two subjects. First, linear algebra. Second, probability and statistics.
Yes, sir. Means, can you elaborate some roadmap type of things, sir?
First, linear algebra. Take a standard book of linear algebra, like Gilbert Strang. Okay. His video lectures are also
Yes.
available. They are fantastic. You can listen to it and learn from him. Second, learn probability and statistics. I already shared the link in the chat box.
Yes, sir.
You can download that book. It's a very good book. Learn probability and statistics concept. Third, so while you do the linear algebra and probability, you can parallelly do the Python programming.
Yes, sir.
And then once these three things are available to you, I think you will be able to understand the concept of machine learning, deep learning, AI easily.
And I'm just from sir field background, means industry background person. Yes. So I am basically from power industry.
Correct.
Utility. So I have gone through your lectures, and all these series are going from last 19th of May, means last 12 to 12 days. So I have one question, sir. How I can implement these things in my field?
See,
Means
you know the domain knowledge. We do
yeah,
not.
have, sir.
Yeah. So we do not know the problems there in the power system. You
Yes,
need.
sir. For example, yeah, for example, sir, just if we have some time, then I can give one small example. Hello.
Yeah, go ahead.
Yes, sir. Like in our, I'm from Madhya Pradesh, Jabalpur. We are having thousand of transformers in whole MP, every district. So we have some data, means their conditional data, like we are just measuring IR values for just their health. So can we predict how much remaining life is they are having? Because this will be useful for our just means planning for the next things.
Yeah, you can do it.
And also failure product failure
100%.
protection. Yeah, failure
100%.
protection.
Yes.
So sir, from where to start, means this thing.
Abhi, just now I told to someone, you were there in the meeting, na?
Yes, sir.
I told the roadmap.
Oh, but sir, such a time I don't have, sir, because in
Then it's not possible.
yeah. No, means there may be some other work I can hire or some collaborate some other things, means some other person.
Whatever.
Because I have to do my own domain work, sir.
Yeah, but the roadmap is fixed, Mr. Srivastav. So you have to go with that roadmap only. Either you do, or if you have a team, you can ask them to do it and report to you, whatever.
Okay, sir. Through this such a platform, maybe some organizer may some arrange some this type of team building or community. So real world
There's
problem
a
can
lot of.
be solved, taken and solved, sir, like this. And
No, there are lots of such organizations, those who are doing such activity. In fact, IIITDM is one of them. If you look at there, you will find good faculties, those who are working in the similar domain.
Yes, sir. Because I am from electricity, means I am doing also PhD,
Yeah, yeah.
part-time PhD,
Good,
but
good.
I am from a utility, means electricity company. So,
Yes.
so many problem. That's why I have also joined this
Correct,
means
correct.
10 days or 20 days
आपको exchange हो
seminar
गया
Yeah, yeah, yeah.
to
I
find
think,
out my solution to my area's problem. Yes,
I
sir.
mean, if you meet Dr. Rakesh or someone who is there in the coordination of IIITDM this workshop,
हाँ हो गया ना इसका 23
I think they will be able to help you for sure.
Yes, sir. Yes, sir. Thank you, sir.
Yeah. Sir, before learning deep learning, we need to be strong in machine learning. Yeah, that's correct. That's true.
So, sir, I think this is time we can end the session today. I think we have covered most of the doubts for
Sure,
the
sure.
participants here.
Sir,
And yeah.
Hello, sir. Hello.
Yeah, I'm here. Please go ahead.
Yes, sir. I asked some doubt. So when we go for learning this deep learning, it's a bit confusing. Some of the places when you go for classification, machine learning concepts are coming. So how to move further? What is the roadmap of starting this? Whether we have to first know the concepts of machine learning, and we have to move to deep learning. What is the thing we have to follow, sir?
No, I have already told the roadmap, Rajesh.
Okay,
If I'm not wrong, I have told to you only. I don't know. So many people are asking. But
yeah,
I already told the roadmap, and this meeting is getting recorded, so you can.
Okay, then I'll go through. Thank you.
Yeah, yeah.
Sir.
Yes.
Sir, in today's meet representation learning, what do we have to learn from this? Do we have to pre-process our own data sets and try getting the outputs?
No. Representation learning means when you have a data in certain higher dimension, but the actual data can be recorded in some lower dimensional, low rank latent space. How can you learn this in a machine learning concept? That's the idea of representation learning. So in the example, we took the example of MNIST dataset, which is actually 28 by 28 images, which is 784 dimensional vector. So these 784 dimensional vectors are converted into a low rank representational space, which is 128. So this is a compact representation of the large data. So if you have in reality, such big data, and if you want to process them, then it needs huge computations. And if you want to transmit it to another place, you need a lot of space. If you learn such representation learning, then you can actually find out the true invariants of the data, and you can actually compactly represent it to understand what actually the data lies.
Compactly represent what?
Okay, so that's actually the point.
So we are at the end time for today's session, and all the participants, sir's credentials will be provided if sir approves us for the same, and you can ask your doubts, queries later on. You can answer whenever he is available for the same.
Yeah, email is there. You can.
Sure. Yes. So now I'd like to, behalf of all the IIITDM, sir, I'd like to thank you for taking time from your busy schedule and giving us these two amazing sessions for the day. That was really, really helpful for us and all the dear participants for the session. And we hope that in future we can host you in a more upcoming better events for the similar interaction and gaining insights from you.
Sure, sure.
Yes,
Thank
sir.
you. Thank you, Ishita, and thank you, Dr. Rakesh. If he is there, if he is not there, just give my regards to him.
Sure, sir.
Okay. And thank you for inviting me. Thank you for having me and listening me. Thank you all participants. All the best. I will share my slides and all to Dr. Rakesh. I think you can take it further.
Yes, sir. Sure.
Shall I leave? Ishita?
Yes, sir. Yes, sir. You can. Thank you, sir. Thanks once again.
Bye-bye.